the title Bias Killer, combining behavioral research and NLP to combat not only gender biases. And we start with two incredible people from PwC. Ahmad, who is director and head of AI at PwC, and Marcel, who is senior data scientist at PwC. So yeah, I invite you on the stage and give you the...
It's on maybe? Okay, good. Yeah. Thank you very much for joining our talk today. Thank you for a nice introduction. My name is Marcel. I'm here together with Ahmad. We are from PwC Austria. We are from the something called Digital Factory, which is basically like an AI team of PwC. And yeah, so today we will be talking about a new tool, an app we are developing right now, which is called Bias Eliminator. And I think this is not working. Is it working now? Oh. Yes, perfect. Okay. Just give it a second. So our tool, just to give you a background story on how we came with the Bias Eliminator, is that nowadays there is a lot of talks about bias in... Perfect, is working now. There's a lot of talk about bias in AI, gender bias, cultural biases, and of course this is extremely important, and there are new methods being developed to basically combat these biases. And so like there has to be like some proportion that's like predefined and so on. There are like some other methods, but we were thinking, of course, whether this is something that we can at least in some aspects combat beforehand. And the idea was that basically, why is AI biased? It's not that like it's evil on its own, right? But it's because the people are biased. And AI's objective is, in most cases, to replicate the behavior of the people as it's reflected in the data, because the data are the reflection of the people's decisions. So we were thinking whether we can somehow flip this and also use AI to do good before the people get biased themselves. That's how we came to the idea of Bias Eliminator. And I will tell you more about what it actually is. And so we were thinking, how can we use AI in which areas, which domains of human and especially work life, where people are already inherently sort of biased, and how can we use AI to augment their decision making and their intelligence to be less biased, to make them more conscious about their own biases. So we were thinking, what's basically the most pressing issue nowadays, like in work life regarding the biases, then it's a gender bias. So for example, if you look at all the kind of statistics, you will find that in the US, the gender pay gap, so the gap between how women and men make, how big their salary is 27%. It would be a little bit less if you would also adjust it for the number of hours, but it would still be quite significant. In the US, this gender pay gap is 13%. If you look at the technology sector, only and the gender division in technology sector, only 27% of women actually work in tech-related jobs, while rest of the people, of course, are men. And the question, of course, is why that less women work in technology, and where does this gender bias actually start? I mean, it can start way back, but there is actually significant research that shows that already when women are applying to jobs, and men are applying to jobs, they can already be influenced by the way the job ad is written. And I will tell you a little bit more about this research, but basically it's like a credible, sizable research that shows that if the job ad uses the words that are stereotypically masculine, it deters women from applying. And this is something that also have been later on proved by LinkedIn itself. So what are the masculine or male-coded words? Are words like aggressive, ambitious, confident, dominant, logic, and so on. So if you have a job ad and you say, we want people who are ready to challenge, consulting problems in a dominant and aggressive way, then this is something that we would call strongly masculine coded job ad, okay? We want aggressive sellers, we want dominant sellers, confident personalities. There are also female coded words that are here, but they are for now not so important, because even if the job ad is strongly feminine coded, it doesn't mean that it deters males from applying to the job ad. So it's mostly about the male-coded words. So of course, they didn't make this up. There's like a sizable, credible research which started basically in 2011 by Gorcher, Friesen, and Kay, which are American researchers. And they ran many experiments when they made people applying for jobs, and they were looking for how much this job is appealing to them and how much will people actually really apply. So if you look at these two nice graphs, you see on the vertical axis, you see the mean job appeal. And you see that female participants were much less likely to apply to, were much less interested in applying for masculine coded advertisements. Yeah, and this was later on. This was like an experiment, and then it was also later on proved by the research on LinkedIn, because on LinkedIn you can apply directly nowadays, right? So you can click apply now. So there it's like for real. It's not just an experiment in a lab. And the more masculine it is, the less women are likely to apply. Yeah. How would you infer that someone is a woman? Because you don't know it on LinkedIn, the gender itself, but for research purposes, how would you infer it or try to estimate it? From a name. So you have like a database of names. So this you need as an independent variable. Yeah, the effect size is 13%. So if you have a job ad that's strongly masculine coded, the women are 13% less likely to apply for it, which means that 13% less women will be applying for it, which is a lot. It's a lot of women not applying for these kind of jobs. And why does it matter? That's the question. Why does it matter? It matters for many reasons. Yes, of course, we work in consulting companies, so advising our clients. We are also trying to, of course, it matters from the societal point of view and from the equity point of view, but also financially it matters also. Because since less women are applying, it means that there is a longer time to fill the job vacancy. You also have to pay the higher wages in the shortage jobs because less women are applying. There is a longer time to find a replacement. So this all basically counts in increasing the costs for the companies. And then so that's like this pragmatic kind of view. And then you also have this social costs of discrimination and so on. Yeah, but we try to make it more practical, basically this bias eliminator, and just say here, look, the opportunity is not just to be nice and more equal to people of different genders or different culture, but we also save money, which is much more appealing to companies. Yeah, so it's nice that you can save money and actually increase the way you treat people. And so, since you can save money, it's actually optimal to remove bias in job ads, right? So it would be better to neutralize it, sort of, so that also women will be applying. And this also isn't just about the women, but there can be words that are culturally biased and so on. But this is what we are working on right now, is the gender bias. So what's the problem here? So let's say that I show you the job ads. So let's imagine that you are an HR person, right? So you are basically underpaid, you have a lot of work to do, and you have to write a job ad and publish it on the website, right? So let's say that I have an app and I show you, oh, you use the word leading, which is masculine coded, so you shouldn't use it. You should replace it, right? Because the evidence shows it, and it will be basically neutralizing the job ad. What's the problem here is that it's easy to label it, but if you are this HR person, you basically don't have time to write it. First, because you don't know time and resources, let's say, because you don't know. First, you don't have time, you're busy. Second thing is that you don't know what to write it with, right? Because okay, so it's leading, so now I can randomly start writing some synonyms, and then it will either show up red or not. Okay, yeah, maybe not the best way. And the thing is that if you do it like this, and there are I will show you, there are many apps on the internet where you can just plug in your job ad, then it's not actionable. Basically, you don't know what to do. So how to motivate your behavior, before we go to the bias eliminator that tries to replace these words automatically, I just want to show you there are numerous apps on the internet that you can use to decode, basically to find what's biased and what's not in your job ad. And one of them, the nicest one that I like, is called Total Jobs Gender Bias Decoder. So, I mean, here they use the red for male-coded words and this green, bluish for the female-coded words. And what do you see here is that leading is like male-coded, challenges is male-coded, analytics is male-coded. Does it work? I don't know. Yeah, okay. But it's not actionable because it tells you, what does it tell you? Your text is more biased than most job ads. We suggest replacing these words, but you don't know what to replace it with, right? So that's the problem. And to make this research bias actionable, we want to automate the word replacement. We want to use the AI for good to automatically neutralize the bias by suggesting you which words to use. Yeah. So what's the problem here? So for example, if you have the word leading, the neutral words that you can use to replace is top and skilled, for example. But the problem here is that for word leading, sometimes the word top is better replacement word, it's closer synonym, depending on the context of the sentence, and sometimes the word skilled is the better synonym, right? So you can automatically replace all the words with just one alternative, but you have to try to fit the context. And that's where the real AI problem comes in, how to fit the context with the replacement word. Yeah. This problem is unfortunately not trivial. So you can use the classic word embeddings. So who knows the word embeddings? You know that like Word2Vec, Tomáš Mikolov, and so on. These classic word embedding models, they look for in the terms of cosine similarity, they look for the most closest synonym for the word leading. But this Word2Vec, this classic word embedding models, they don't take into account the context of the word. The sentence and the entire job ad. So you have to use something better than the classic word embedding models. So if you would go more like a few years after the word embeddings models, you would find something that's called Elmo embeddings, which are basically changing the cosine similarity of the replacement word based on the context of the sentence. Yeah, and then it's like quite short way to arrive at the transformer models, which would replace the word with the words that are fitting the context. Yeah, so that's what we are using right now. We are using the Roberta model, and for now we are using basically the mask to use the replacement word. Yeah, for example, Roberta is the transformer model that's derived from BERT, which is trained on like this mask language modeling, which means that you for example, in this sentence, let's say that I want to replace the word distrust. So I have the sentence called, at the core of the United States mismanagement of the coronavirus lies its distrust of science. So I want to predict this word distrust, and I would mask it, and then the model has to predict the word that's like mask down there. But it wouldn't really work. It would work like in the sense that it would take the context of all these like neighboring words and sentences, which is something in the input, that you ask the model, but denial, ignorance, abandonment, and neglect are not really that close synonyms. So we had to use sort of a twist in the query to the model with these masks. We try to inject the characteristics of the original mask word into the sentence. So it turns out that it works quite well. So what you have to do is that you put the sentence where you try to predict the mask word twice into the query input, and first you leave the biased word there, and then you try to predict the biased word, and this way it injects actually in this like embedding of this entire input, it gets changed in the vector space because this original word injects the quality, so the model can find the closest synonym. But at the same time, the mask words the biased words on the biased list, there's like 150 words, are already like ruled out. Yeah, so it's what we are using right now. The other ways how to do this would to be using k-nearest neighbors to try to fix the context. But for this, you need to have a database of job ads, which we don't have yet, because we will collect it when we start using the app with our clients and for PwC itself. Yeah, so it would work better. This works better when you have like these two sentences and you try to basically provide a model with the biased word. Yeah. And we are already developing the app is the name of this talk, called Bias Eliminator. So you have to like log in with this identity. That's how it looks like. What you do is that you would just copy paste your job ad, or you can also put the Word document. Yeah, then it highlights the biased words. For now, the blue is the male-coded and the red is the female-coded, which reinforces the biases, but for this presentation that only has 25 minutes, we chose to go with the biased colors because it's easier. But what's new here is that here to the right side, you would have AI suggested replacement based on the context using this mask modeling, and then also for the each word you can click and use for the the selection of the replacement words. Yes, so to be fair, we took our own job ads, like not from Digital Factory, but of the PwC in Austria, and we looked whether we are biased. Of course we are, because everyone is biased. And yes, so this is the senior associate in Unternehmensberatung is the management consulting. Yeah, so you can see that you task in team advise the leading insurance companies, blah, blah, blah. So leading is already mail coded, challenges is mail coded, analyze and challenging is also mail coded. This is how this suggested thing looks like. So you can see that leading is suggested to be replaced with top, challenges with problems, support with sustain, analyze with explore. And this way, so to the left you have like, for each word you have the best suggestion. And you can also look when the top wouldn't really work, you think, then you look at the leading and the suggested replacements are top and skilled. Of course, it often gives, the masked prediction would give you other biased words as a replacement, so this is automatically excluded on the lemma level. So any kind of, so you lemmatize the biased word and then the replacements to compare whether it's not also a biased word, yeah. And for challenges, you can have problems, hurdles, issues, and so on. Yeah. This is nice, of course, I would say. People like it, but the thing is that, of course, no suggestion by AI is perfect. So we sometimes want and need to keep the human also in the loop for the continuous retraining of the model. And how do we keep human in the loop? It's that the users can rewrite the biased word. So you have the word leading, and you think that at this time, no replacement by AI is fitting you, so you suggest, so you rewrite it basically, or you suggest another word, and then it will again check whether it's biased, because we have this original list of biased words. This is extremely important, because otherwise the humans, the users could put the bias back, or train the model on the new biases, right? As you saw yesterday with this Microsoft Twitter bot that just became like a Nazi robot and so on. So this is always a check that we have in place. And yeah, then we check it against list of bywords, and then we use the continuous retraining and fine-tuning of the model to make it better. So over the time, the app will get even better. And now Ahmad will tell us a little bit more about this MLOps part, because it's also quite non-trivial. Thank you.
Thank you. Thank you, Marcel. I think the good news is that we have 60% female in PwC Austria, so it's still working. Yes, my name is Ahmad. I'm director at PwC Austria, and I want to talk about the most important part of our MLOps pipeline there, which is the fine-tuning of the transformer models. So we use transformers, and transformers, for example, like GPT-3, they have been trained on 400 billion of examples, and they have about 173 billion of parameters. The ratio is okay, so we have like almost 2 times more examples than parameters. But the question now, if I want to fine-tune a transformer with few shots or one shot feedback from users of the Bias Eliminator. Is this possible? We need to fine-tune 173 billion parameters with a few shots. It's not possible. And if it's possible, basically, you're most probably going into this forgetting or catastrophic forgetting and removing all the knowledge of the 400 billion examples that is trained on. So we need to train this model, but we need also to keep the knowledge of transformers, which is trained on 400 billion of examples. Do we expect to get 400 labeled examples from the users of the Bias Eliminator? It's also not possible. We are not that high scale. So this is why we suggested basically this kind of framework of augmented intelligence, which is basically a way how we can fine-tune our transformers. Which we use it for the Bias Eliminator, but also for most of our human-in-the-loop tools, where you have a user, and user is giving feedback to a tool, and the tool is basically learning from user feedbacks, and we closing the gap between manual work and actually full automation. So it's like augmentation towards automation at the end. And here, basically, I'm just showing we have a stack in this framework of 3 models. This the shape here, the dimension is basically just the number of training examples and number of parameters. And the first one here we have, I'm representing the transformers. Okay. So we have actually consecutive stack of 3 models, and these 3 models actually the decision is running through from bottom to top, so from the transformers to the next model, which is a shallow, small, mini batch learning model. And then one on the top is basically one-shot learning. The one-shot learning, first one, is basically used to apply immediately the user feedbacks on the document. So if I am working on a document, and I have a word, for example, Austria, in this document, and I give it a label, whether it's for the bias killer or any other NLP task, then I expect that all the present first of the word Austria in the document would be changed based on my labeling as a user. And also all the similar words need to be also changed. In like similar, I mean like, I don't know, Serbia, Germany, because they are similar in terms of the context in general. This is like the one-shot learning, but the few-shot learning or the shallow, small, mini basic batch learning used to gather the learning from all users and update the knowledge of the model. So we have 3 models, and I will talk first about the one-shot learning, which I call the hash table of similarity. If you are a software engineer and you are doing a coding interview, the answer to most questions, or the first thing you think of, is usually map or hash table, because it has this kind of memorization. It's actually reduced the time complexity. And here we are using it, but how we are using it. So once we apply a document to our transformer models, while we are predicting the output, we are also collecting all the encoding of the words in this document. Then you apply kind of similarity clustering. So you can either do kind of unsupervised clustering, and you try to group all the words in a document into different clusters, or you apply what is called the one-shot learning networks. For example, there is a CMEs network that takes 2 inputs and predict whether they are similar or not similar. So it's like trend network to predict similarity between 2 words. Then basically apply this kind of hash table. For example, the word Austria, in the same word, we have similar words. We have a list of similar words, for example, Serbia and Germany, and the same case for Serbia and Germany. And now if the user apply corrections on Austria, then I directly know that there are other words in the document that are similar to this, and I give them the same label. So instead of searching for these words or searching for similarity always inside the document, I have this hash table ready that I actually generated during the processing of the document, and I can use it directly for that purpose. The next step is the shallow model, which is basically coming after the transformer. This is also interesting. So we have the first reset. And here I'm just showing very simple example of 2 dimension. Of course, transformers, they have higher encoding, about 700. But here, like very simple, like consider 2 dimensions. And the first thing, we are resetting the dimension by generating random data points, here like just uniformly, with a label, we call it unknown, because we have this feature space and we don't know yet what decision we make there. The second, let's say we get like few shots, which we get like 1 example for class A and 1 example for class B, and they're actually in this position. Then I train this simple classifier, which is basically radial basis Gaussian function, like SVM, radial basis, where I strict basically the decision around the 1 shots that I got from there, or few shots. And the rest is unknown. So remember, like, if I get a new point that is very close to user feedbacks, then I would classify them either to class A or B. If they are far from this basically 2 point and they are in the region of unknown, they would be classified to unknown, because for the shallow, it doesn't know yet the decision of this area. Okay? Now, how can I combine the 3 models in terms of kind of voting system? So it's like this. We have this rule. Like, of course, if they're like the transformer, shallow model, and the similarity one-shot, they all say it's class A, then it's the prediction A. If, for example, the similarity says B, then it will override everything, because it's coming directly from users on the document. So like it's 100% sure that this word needs to be changed to something else. So that's why it's override everything. Now, if B is unknown, because the similarity model is unknown because there's no feedback at all yet from users on this word. But the shallow model says that it was 90% should be B because actually it's very close to one of the points that we have already gathered information about, then it will be. Now, if basically transformer says A, and the point is in the unknown area, which means unknown, and there is no user feedback, then I get the transformer. And in this way, basically, I'm protecting the transformer learning, this with 400 billion examples. I'm not changing this general language understanding. I'm just fine-tuning it with a shallow model. And also, I'm helping the user experience by applying their fast feedback on document by using this similarity model. So this is like our framework of this augmented intelligence in general, which is we see it here basically in the MLOps pipeline, where we have first the large model MLOps, which include data preparation, data training, modeling, deployment. And we have the same for the shallow model. The only difference is that when we have actually user feedback, they would start in short-term memory. And then when we want to pull this data to train the large model, we pull it from the short term. And we free the short-term memory. It's like cache, you can consider it. We reset the shallow model and we retrain it. So this is basically the process of our MLOps. And yeah, thank you so much. So basically regarding the bias gender, or the bias, sorry. So we have what is next basically is not only about the gender, so we are basically covering other like culture and other biases. We would like to use that for other biases, and not only for job posting. So everything related to bias in NLP. And yeah, so thank you so much, and we're happy to receive any questions.
We have 2 minutes, so if anyone wants to ask a question. If not, thank you for the fascinating presentation. Oh, okay.
Thanks a lot for the talk and bringing this topic here to the conference. Yeah, I think it's definitely important, especially if there are unconscious biases, that they're also eliminated. My question would be, like, has PwC also done some research on whether the language you see in the job ad reflects some kind of the culture of the company? Because I would say, well, if there actually is a toxic environment in the company, it should be rather reflected already in the job ad as well.
Yeah, it's, you can answer part of it, but from my experience, it's not, because usually the HR is split from different teams. So this is how you split the bias. Of course, if the team leader is writing the job posting, then probably yes. But in our case at PwC, it's mostly the HR, they are writing the job posting. But of course, because it's consulting, you do have some kind of requirement, I would say, and this is why we have not mostly, but we try to basically to balance between males and females in the company. Yeah. But it's like consulting, which means as a data scientist, you need to have other skills, not only the technical skills, because you need to have skills related to your soft skills, because you would be presenting to client, working with a client. This is definitely biased against data scientists, not against gender. But yeah, this is from, do you have any questions or answers to that? Other answer?
Does basically answer what you say, but like, yeah, we were thinking about also, because some other basically consulting partners are interested in also detecting, for example, the toxicity of company or company cultural style and so on. But for this, you need to first have labeled data as they got in the experiments. Yeah. So, but it's the direction we also want to go through. Yeah. Follow. Yeah.
Thank you.
I would have one question. You mentioned that you're using Roberta to get these synonyms, and then at one point you're using this step of getting the unbiased words. And these unbiased words, this list of words, is it something that is in a way overseen by humans, or how do you do this, and how do you include this step in the whole process?
So that comes actually from the beginning, from the experiments, the original list of biased words, and it's. I mean, there were multiple ways how they got it, but first, the usual way is that like you give people just like random words, and they rated how masculine and how feminine they are. So that's how it's coming through. The more sophisticated way is to randomize the text of the job ads, and then look which words are differentiating whether women or men will be more likely to apply. But there is a list of these like 150 words coming from the 2011 paper that are always used like the gold standard, which also ensures that you cannot bias the AI back, at least regarding the gender things. There is some other research from last years, but we always use this gold standard 2011, yeah.
Okay, thank you.
Sure.
Thank you.
Yeah, we're running out of time. Thank you for the fascinating presentation.
Thank you so
Thank
much.
you.
Once again.